Hello friends, myself Nimisha. Welcome to ACE Academy. Question is, prove that under root 5 is irrational. Before solving this example, let's see definition of rational number, irrational number and co-prime. So definition of rational number. Rational numbers are numbers that can be expressed as a fraction p upon q, where p and q are integers and q is not equal to 0. Means rational numbers are those numbers which can be expressed in form of upon, that is in form of p upon q, where p and q are in integers and q should not be equal to 0. Now decimal representation of this rational number can either terminate or end or be non-terminating or repeating. Means their decimal expansion is terminate or it may be non-terminating or repeating. For example, 1 upon 2. It is a rational number. Its decimal representation is 0.5. This 0, after solving this example 1 by 2 or after division, we get 0.5 as decimal representation. So it is decimal representation of 1 by 2 which terminates. Means we get answer easily as 0.5. But if you take example as 1 upon 3, which is also rational number, so its decimal representation is 0.3333 and so on. So it shows that this 3 is repeating. So decimal representation of 1 upon 3, which is non-terminating but repeating. So we can say that it is example of non-terminating, repeating rational number. So irrational number that cannot be expressed in form of p upon q. So these are irrational number are numbers which cannot be expressed in form of p upon q, where p and q are integers and q should not be equal to 0. So decimal representation of irrational number are non-terminating and non-repeating. For example, so its decimal representation is, they are neither terminating nor repeating. For example, under root 3 is irrational number. Its decimal representation is 1.73205080 and so on. Means it never terminate and never repeat. So under root 3 is example of irrational number. Pi is also example of irrational number. So pi is equal to 3.1415926 and so on. So it is also example of non-terminating and non-repeating. Now we see what they mean by co-prime. Two or more positive integers that have only one as their HCF, that is highest common factor. So co-prime numbers are those numbers which has their common factor is only 1. That is their HCF is only 1. Question is, prove that under root 5 is irrational. So we prove this example using contradiction. So we write solution here. Let us assume that under root 5 is rational number. If under root 5 is rational number, then it can be expressed as p upon q. Therefore, under root 5 is equal to p upon q, where p and q are co-prime. Where p and q are in integers and they are co-prime. So, now squaring both the sides. So we square both the sides. So we get 5 is equal to p square upon q square. So we give this as equation 1. Now we can write this as q square is equal to p square upon 5. Give this as equation 2. From equation 2 it is clear that p square is divisible by 5. So from 1, it is clear that p square is divisible by 5. Now we can write this q square as p multiplied by p upon 5. We put this as equation 3. Now from 3 it is clear that p is also divisible by 5. So it is clear that P is also divisible by 5. So we can write this P upon 5 equal to C. Means if you perform its division, that is P upon 5 if you solve this. So we get answer as a C. So we can write P upon 5 is equal to any constant C. So P is equal to 5C. So we put this as equation 4. Now this P equal to 5C, we put this in equation 2. That is Q square is equal to P square upon 5. So put 4 in 2. So equation 2 is Q square is equal to P square upon 5. So Q square is equal to the value of P is 5C. So we will do here 5C square upon 5. So it will give 25C square upon 5. So Q square is equal to 5C square. Now this C square is equal to Q square upon 5. So we give this as equation 5. So from 5 it is clear that Q square is divisible by 5. Therefore, C square is equal to Q multiplied by Q upon 5. Put this as equation 6. From 6, it is clear that Q is also divisible by 5. So, from here, you can see that Q square is divisible by 5. Then Q is also divisible by 5. Therefore, 3 and 6, it is clear that P and Q are divisible by 5. Divisible by 5. But we assume that P and Q are co-prime. If P and Q are co-prime, then they do not have common factor other than 1. So they do not have any common factor. But here from 3 and 6 it is clear that P and Q are divisible by 5. So, but it contradicts our assumption that P and Q are co-prime. Therefore, under root 5 is not a rational number. Therefore, under root 5 is irrational. Hence, proved. If you like this video, please share it with your friends. Please like and subscribe my channel and press bell icon to get more updates. Thanks for watching it.